real-time analytics platform to look at travel market information. And so that's things like looking at how many people are searching for flights to a specific city on any given day, how many hotel bookings are happening, looking at market demand and supply in real time. And one of the biggest tools that I'm using is Storm. And so I've been working with it for about 6 months, and I've done some pretty interesting things. And so I wanted to kind of go over what I've learned with that, so anyone else getting started can use that. So just in terms of the talk overall, so I wanted to touch on distributed systems and batch processing, talk about streaming processing in general, introduce Storm, and then I've got a word count demo. So I want this to be relatively hands-on for anyone that brought their laptop. So then with that, we can see Storm processing in action, and then take a look at the architecture of what Storm looks like and what it does, and then go back to the demo to look at a little bit deeper level so we can see how it's doing that processing, and then kind of open it up for discussion about the kind of use cases that Storm makes possible, and open up for Q&A, and we can we can do some additional hacking with the code example if we have time for it. So first off with distributed systems, and also, so from the intro, it sounds like pretty much it's mainly engineers, not too many data scientists, but maybe some engineers moving more and more into the analytics data science space. So I'll keep that in mind as I'm talking. So how many people are familiar with Hadoop that have used any kind of horizontal scalability platform like that? Most people? About half? Okay. So the basic idea is as data volumes grow larger and larger, we can't fit them into memory on a single box. And so for any framework that allows us to use cheap commodity hardware to do that processing and spread it across multiple boxes, that's just a win. And Hadoop is obviously the poster child for this kind of processing. But the limitation with Hadoop is that it's mainly batch processing, and so you really can't do anything real time with it. So so a couple of the problems you see are data latency, where in order to get your reports, you have to wait for the Hadoop job to run, and the old mode of doing a batch process nightly to publish reports won't work for any kind of enterprise that has global clients. And so for that and a variety of reasons, there's an increasing move towards streaming processing. So streaming processing in general, so it gives us a real-time view into any data sets that we're processing. And then really that opens up whole new use cases like real-time intervention and responding in real time. So as opposed to the old style of seeing what happened after the fact, now we can see it as it's happening. And in the case of travel market analytics, we can see spikes in demand for, say, flight search or hotel search as they're happening. And from that, we can infer that events are happening in cities. So there are several frameworks that do streaming processing. So Spark is one. Azure has one called Streaming Analytics, which is pretty cool. And AWS is also playing in the space with kind of a combination of Kinesis and Lambda. I don't think they have much in terms of horizontal scalability yet. And then, of course, Storm. So Storm, first created by a guy named Nathan Mars, first used in Twitter, and kind of the banner is to do for real-time processing, or to be the Hadoop of real-time processing. And then just in terms of what we're processing here, data streams, the definition is really an unbounded sequence of tuples. Tuples is just a collection of values. So let me go ahead and run the demo here so you can see it in action. And then we can also take some time for individuals to get up and running on their machine.
Brendan, is there any way you can make the font bigger?
Under view, right, just now? Yeah, Command X, or Command plus.
That's just, is that increasing the font size at all?
A little
Yeah,
bit.
the window, yeah.
Okay, so can people generally read this? So what we're seeing right here is, so I've started up Storm locally, it's running on my machine, and it's generating just random sentences talking about different kinds of fruit. And so as those sentences get sent into the topology, I'm counting the frequency of words that are happening. So word count example is kind of the hello world of the big data analytics space. So I invite everyone to try this on their laptop if they want to get this up and running. So I posted the code example on the data meetup.
So it's cloned from that?
Yeah, so hit here, grab the clone URL. Actually, I can just walk through this. So just create so if people want to follow along, so just create a directory, clone the repository. And it should create a directory here. So go into random drive, and then there's a command that will run it for you. This maybe install just this whole piece here. And then if you have Maven installed, that should be all it takes to get it running. So it'll take just a few seconds to actually start the topology. And then when you see it talking about fruit, you'll know that it's running.
So for this, you pointed it at you got like a mock or a fake or something that's talking about the fruit, but in reality, you would point this at some other stream of data.
Yes, exactly. In this case, it's just generating just random sentences. It just has an array in memory that it's looking through.
Mm-hmm.
But yeah, in reality, this would be talking to some queue, or it would go and ping some API to see whatever new data there is, and then submit that into the topology for processing.
So, Brendan, one clarification. You wouldn't point this at a data, you would point stream at it. Or is it the other way around?
It depends on the implementation of the spout. So the spout is the component that Storm uses to integrate with whatever the external data source is. And
Okay.
some will be push, some are pull.
Sure.
Can it listen to like a message bus or something and not disrupt the message bus?
Yeah, and you're free to implement whatever logic you want in the spout itself. And I'll go that into more detail in a little bit. So are people able to run this, or are they running into any issues?
What's the command to run The one in the readme, right?
Oh, it's that in the
Yeah.
Okay.
So it's just the name clean install with the zip Java. Are people able for me to run from there?
Mine's still installing.
Okay. Yeah, it might take a couple minutes for it to download any dependencies. So, about, do people want to spend some time to get running or talk about Storm architecture?
Go ahead.
Okay.
One question I had, how is Storm and Spark different? What is the difference between Storm and Spark?
We can touch on that later.
Okay.
So I've actually just started playing around with Spark.
Okay.
So, well, yeah, we'll discuss. So in terms of the actual infrastructure for running Storm, so you have the Storm cluster itself, which is the physical machines. And so what you have as the master node in the cluster, you have a service called Nimbus. And that's the master controller for your Storm cluster. And Storm uses Zookeeper, open source framework, to coordinate between the components in the system. And the supervisor nodes are the ones that actually do the work. And so all the processing happens on the supervisor nodes. So some of the benefits of using Storm are you can add supervisors while your topology is running, and then rebalance your topology across the new servers. So without interrupting data processing, you can increase capacity. And then more specifics on the actual components. So the supervisors run one or more JVMs that are referred to as workers. And workers run executors, and which are Java threads. And executors run tasks, and tasks are instances of spouts and bolts. So the spouts and bolts are where your actual processing logic are defined. For the topology itself, so the topology is what does the processing logically. You can have one or more topologies running on a Storm cluster. So you could either have one well-sized cluster that runs one topology, or you could have a massive cluster that runs multiple topologies. The term here that you can use is DAG, or directed acyclic graph, which you see down on the right. So you have spouts, which are responsible for talking to an external system to get data for processing. So typically listening to a queue like Kafka. And then those pass the data to individual bolts, the lightning bolts that you see, to do whatever arbitrary logic that you've programmed in. And you can have, so generically these are referred to as components. And so a component can listen to multiple upstream components, and it can push to multiple downstream components. And so that's the definition of the topology which you program in to suit whatever processing you need to do. And so the task itself is an instance of a spout or bolt. So say for a bolt, like in the case of the word count example, as words are coming in, it's keeping track of how many of a given word it's seeing. And what Storm does when I submit that topology to the cluster is that it instantiates multiple copies of that. And I can tell it ahead of time how many instances I think it should have. and then it will then apportion the work across all available instances of that bolt. And please jump in with questions if anything doesn't make sense.
Can you briefly explain the word counter using this diagram?
Sure.
Could you repeat the question again? Sorry,
Uh,
can't really hear from here.
I asked if he could explain the word counter example using that diagram.
Okay.
Like what is a spout, what is a bolt, what would they do given that example? Oh, and it's your next
Anticipate
slide.
the next slide.
Yeah.
So for the word count example, you can see the topology at the bottom here. It's about as simple as you can get. So we have one spout that is just randomly producing sentences, and then sending that to the sentence tokenizer. And that is just breaking up the sentence into individual words. And then the sentence tokenizer sends the data downstream to the token counter, which just counts how many words it sees. And so between any two components, you specify what the grouping is. And so for and I don't really have a diagram of this, but for any one of the components here, you would have multiple tasks. And so one task does some amount of processing and then sends the data downstream to another task. So you would have multiple tasks that comprise the sentence tokenizer bolt, for example. And then in the grouping between the components, you specify how you want it to send data from and to different tasks. So if you say you have a shuffle grouping, then you're saying, I don't care, just send it to, send the tuple to any task. But in the case of the fields grouping, you name a specific field in the data stream, and what it does is it sends any tuple that has a specific value, it sends to the same task. And so in the case of the word count, I'm grouping on the word itself so that any occurrence of a word is sent to the same task. So I can do any stateful processing, in this case, keeping track of just how many times I've seen that word. Yes?
So can you clarify are the tasks equivalent to a bolt, or bolt has multiple tasks within them? Can you clarify that?
Sure. So essentially the bolt is the class and the tasks are the objects. So
Are the instances?
yes,
Okay.
yes, yeah. So one bolt will have multiple instances, and those instances are referred to as tasks.
So doing the same thing, but maybe with different input.
Yeah.
And
or
also
yes.
on different parts of the cluster. Is that how it scales out?
Yes, yeah. So Storm will then take different tasks for the same component and spread them across different worker JVMs on different machines. And it tries to do that as uniformly as possible so that it gives you high availability. In the case that a single node goes down, the processing for that particular bolt is still happening on other servers. So let's take a look at the actual code. Okay, is this too small to see, or?
It'd be nice to be a little bigger.
Pretty small.
Just Command plus.
Yeah, I think you hit Command plus maybe 5 times.
Doesn't do it on that? That's weird.
Eclipse isn't having it.
Bummer.
And the Eclipse preferences?
Can you full screen it at least?
No time to change the font.
Yeah.
Yeah, go to Eclipse preferences. Yeah. Oh, it was higher. Java. It was Eclipse preferences. Do you do font again?
Is it in this one?
Yeah, on the right, you see Java right about 40% now. Yep.
Pain.
Yeah. Can't quite see.
I think it's the last one, properties file, filter.
Sublime text.
Yeah, and then go edit button on the right. Go edit again. I think we have don't dismiss it before you apply it. Oh, edit. I got it.
Maybe go to 24.
Yeah, it's a,
I didn't see anything.
Otherwise, I'll just zoom in with the camera. We can watch it later.
okay. Yeah, that's not good.
Yeah.
Well, I'm gonna invite people to follow along on their own laptops.
Sure.
Clearly that part wasn't made by Steve Jobs and his team.
Well, Sun
My font
Microsystems
size
did it,
doesn't
right?
really mean font size.
Making it easy to use.
Yeah, I know.
Okay.
It's not Java's
Okay,
fault.
so I really only have 4 classes here. So we have the sentence producer, the sentence tokenizer, and the token counter. And then we have the class that actually built topology. So for the topology itself, you instantiate this topology builder, and you instantiate your bolts and spouts, and then you just set them according to the processing that you want. So I set the spout as component number 1, and I set the sentence tokenizer that splits the sentences into words as component 2, and I tell it to listen to the output from component 1 in a shuffle grouping. And for the third bolt that does just counting of words, I set it as component 3, and I tell it to listen to the output from component 2 according to the field token. So that means all tuples that have a given value for the token field will be sent to the same task for the token counter bolt. And then I just submit the topology to the cluster. So for the spout, so in this case, so when you bring Storm in as a dependency, all you have to do is just implement iRich spout or iRich bolt in order to create your spouts and bolts. So in this case, you implement the next tuple method for the spout, and this is where it would either go out to another system to look for data, or maybe it would already have it in memory. But from whatever fashion you need to do it, this is how the Storm topology gets its external data. Here I'm just randomly generating a sentence.
But instead you replace that with some kind of connector.
Yeah, yeah. And there's a pretty huge library of existing spouts to connect to Kafka or different message buses. There's a Redis spout as well.
Like Twitter.
Yes.
Oh.
So for the sentence tokenizer, so this is one of our bolts. So the execute method is what we're interested in. And we are set the tuple. And so this is where we just implement whatever arbitrary logic we have. In this case, we get the first value in the tuple as a string and just split it into individual words. And then with every, and then we just emit that new value downstream to whomever is listening. And if you've done MapReduce jobs, the collector emit should look pretty familiar.
So here you're using like split with a space, right? And you're saying look for empty spaces in anything that denotes the end of a word.
Yes.
Could you use something more, I don't know, tricky to get like words or phrases, like if you were looking for Banana Republic versus Nordstrom. Nordstrom's is one word, Banana Republic is 2 words, but it means one thing.
Yes, yes. Yeah, yeah, depending on whatever logic you have, you would just put it here.
Do you have
Just
any helper
replace
stuff that
with
comes
your
with it,
own.
or for stuff like that, or?
I'm sure
You
for Storm,
replace
it's,
with your own tokenizer function, right?
yes.
Just instead of sentence dot split,
Mhm.
just like,
You could do a dictionary lookup, there's a bunch of
Yeah.
things you could do.
Hmm.
Yeah, that would be a good suggestion. So in this case, so we receive one tuple, but for each tuple we then emit, 0 or more. So here we're kind of fanning out the stream in one dimension. For our token counter, and also the thing to keep in mind is essentially this is just doing a map reduce. So tokenizer is essentially mapping the input to individual keys, which are the words. And then our token counter, we're doing the reduce function, which is as we get in individual words, we keep track of how many we've seen. And so keep in mind that this is listening to the sentence tokenizer through a fields grouping. So each instance of the word will be sent to the same task for this bolt. And so in this case, we have a member field that tracks our state. And so when we get an individual word, we check to see if it's in our map. And if it is, we just increment the count. We're emitting here, but no one's listening. And so the way we're getting the output here is by using something called a tick tuple. And so that's something built into the Storm framework where on task startup, you specify how many seconds or minutes you want that tick tuple to come in. And so that way the bolt has a sense of time. And so then what we're doing is, essentially we have a tick tuple and then we have a data tuple. So we're doing aggregation when the data tuple comes in to count words. And then when the tick tuple comes in, every 10 seconds, as specified here, we just print out the counts that we've seen so far, and then also reinitialize the counts. That's a relatively common pattern where you're just streaming in data, aggregating it, and then on whatever time window you specify, then you send a small chunk of aggregated data downstream, or save it to the database, or do whatever you need to do with it. Yes?
so in a real world, we are going to have many bolts, right, for a given, or many instances of this class running, basically many bolts running.
Mhm.
How do you aggregate all of the outputs together?
That's a really good question. So in this case, in a real world scenario, you might have 5, 10, or 20 tasks representing this bolt, and each one of them will have some subset of the entire key space for all the words that we have. And so each one would be emitting those downstream. And then the problem is, well, how do you get access to that entire data set? And the typical answer is that you put another bolt behind this with only one instance, one task that is listening. Yes, so that the single instance is sent all the data from the tasks that are actually doing the aggregation. And then that tuple, or sorry, that bolt then has all that data and can do whatever it needs to do. Okay. So any other questions on the word count example here?
I have a question related to windowing, like Azure Stream Analytics provide windowing functions
Yes.
where you can like hop a window of particular size and then
Mhm.
do some analytics on that. Can we do something similar here in an easy way, or do it like some detail code?
You mean like a sliding window?
Yeah.
So Storm itself does not provide that functionality.
Okay.
There are a couple frameworks that can sit on top of Storm. that can do that for you. Or you end up writing your own sliding window function. And actually that's what I've done so far. But yeah, Azure Streaming Analytics does have some nice support for that.
So, you mentioned field grouping, right? So in data that's basically a string, how would you kind of specify the field by which you would want to split the data?
I think you would have to process it first to pull out whatever value that you want to use as the key to group on. Or you have more, would that do what you need to, or?
So the fields grouping would be in the topology class, right? Where you would specify the field on which you would want to split the data.
Yeah.
So you would do processing before setting that board?
Yeah, so you would typically, I mean, one thing I've done is you have essentially like a mapper bolt where you get whatever data package you have, and then you have a function to assign a key to it, and then when you emit the next tuple out, you emit the original data object that you had along with the key, and then any downstream bolts just listen to it with the fields grouping on that key, but then they still have access to the original object. Yes?
So thinking about the sentence split that function. So if I write my own function, somehow it's too complicated so that it took longer than the tick, what would happen?
Your topology wouldn't run very well.
Okay, it would still run, or it will just won't even work? How do I solve that problem? I'm thinking about it on the data side, like for instance, if I do the voice type of thing, it might take quite a bit of resource to compute.
So in that case where your function takes longer than the tick tuple, you would just have tick tuples, the tick tuples would actually queue up.
Okay.
If you're still processing that data, then that component is not going to accept any other input until it's done.
Oh.
So the ways to handle that either are to create more instances of that component so that each one can handle a smaller size data set, so that it'll be faster as it's processing. Or you can do something where you have you break your processing into smaller size chunks and can be handled sequentially by multiple bolts.
It's sometimes it's doable. Sometimes, especially in the data science scenario, sometimes you prefer to have the whole thing also.
Yeah.
You're dealing with
You
audio?
wouldn't use streaming, right? Would you